Well, hi, good morning. Thank you so much for coming and keeping me company while I work on this radio. This morning I think I'm going to go after the remaining capacitors in the audio circuits of the radio. I've done one so far, and I think there's three more, two more, three more. There's one here, and this one. This is the audio capacitor here, so the tone capacitor. So I think I'm just going to do these three. What I'll do is I'll look each one up on schematic, try to determine what its purpose is as best I can. Take it out, test it, see how bad it was, put a new one in. I don't think this is going to affect the sound of the radio at all, but it certainly can't make it any worse, that's for sure. So we could start with the easiest one, but let's not. Let's start with this one. So this one is connected between a terminal strip sitting here, and it would look to be the ground side terminal of the volume control. And so there's a chance that this is just simply being used as a ground terminal. Would appear to be the case because the wires coming from this terminal the capacitor is hooked up to, going over to the tube where there's two terminals tied together and a bunch of stuff hooked up to it. And that's all screaming a ground point. Well, maybe I can actually see it because it's always better to operate without assumption. That's pretty tough. Big a splash of solder here on the chassis. Something is soldered to the chassis right here. Just look at a couple other tubes. So maybe up here you can actually see it a little better. This tube has one of its socket rivets soldered nicely onto the chassis, clearly done before there were any parts inside the radio, and the same thing's been done down here, but I don't see a wire coming from it. What I do see in this tube, one terminal, it's as if it's been bent over and soldered to the tube socket frame, I don't know what to call it, which is then soldered to the chassis. But that's not the one we're interested in. We're over here. Well, I don't see any direct connection to ground. Let's take a look on the schematic. We'll look for this capacitor. We'll see if we can spot this terminal strip here. And you know what? There's another wire. Can't really see just in behind here right now, but there's something more going on back in here. Let's look at the layout diagram first. See what it shows. Okay. Okay, here we are. Now we're interested in the volume control. Where are you? Here we are. Volume control. There's a capacitor laid in right here. So here's a terminal strip, three connections to it. That's the same as the strip I'm looking at. So and this capacitor C17 is going to the same terminal from which the wire travels over here. Here you can see on this diagram there's a connection down to here. So I couldn't spot that. This is the area that's soldered onto the chassis. And this other side is they've bent this terminal down to meet a terminal here and soldered them together. So this terminal is also grounded to the chassis. So that's what's going on. So the ground here is simply brought over on this black wire to this point. So this part of the volume control, this part is grounded to the chassis. So the fact that the capacitor comes here, it's just finding a ground point. What's more interesting is what's going on the other end of it. So one of them is a resistor, which is sitting right there. I can see it. Looks like a 10K to me. And this other wire, oh, over to the tone switch. So I think this is the tone capacitor here. So this is a resistor. It's like a filter here. I have a resistance and a capacitor. It's like I've got some kind of filter arrangement here coming onto the this terminal that's sticking out the back of the volume control. So it's another one of those tricky things engineers do to affect the tone of the radio. How they've done this. So let's look on the schematic now. C17 and R16. So look around here. Let me see. I'm just looking for the number. C17. Where are you? There's R15. C17 right here in front of me. Okay, so we have the back, sort of the tap on the back of the volume control. We have this resistor, 10K, just like it looked to me. And then we have the capacitor going to ground. And we have a tone switch, it's a three-part tone switch. Oh, that's right, I noticed that last time. But there's no three-part tone switch in this radio. Unless the idea is you switch it in the middle and there's nothing. Where to go here? Yeah, switch it in the middle and it's grounded. Well, there's definitely a middle position on the switch. Listen, you can hear it snap. 1, 2, you can't really hear it. 1, 2, so there's 3 positions altogether, starting 1 and 2. And the one in the middle appears to be connected to nothing. Not like this. Okay, so you have three possible tone settings, I guess, is how this is working. You have this capacitor in one case, and the other case you're, let's say, well, what are you doing? Oh, you're moving the ground, what you're doing. You're grounding this. Is that right? That's not right. Oh, yes. Oh, yes, I see it now. I see it now. So my tone switch has 2 settings, not 3. And one is grounded like this. No, I won't put it that way. That's not the right way to put it. I gotta look at that switch more closely. Let's take a look at that switch. There's something about it. Okay, so the switch is right here. And you can see there's 1 terminal, 2 terminals. Where's the 3rd? But when I snap the switch, it will stop in the middle with no contact. But this switch, switching bar, or whatever you want to call it, is making contact at the back here with some metal. It looks to me like this bar is the ground point. So you're putting a ground here, no ground, ground here. Okay, is that really what's going on? I think that is exactly what's going on. It's amazing how you can do hundreds of these radios and still come across something you've never seen before. Not that it's a big deal or anything, but it's something. So we're just going to check to make sure ground is where we think it is. So I'll put this in the sort of the neutral position. Sure enough. So you're literally switching the ground. You're literally switching the ground. You want to say that again? No, twice was enough. Okay. Okay, so I think that makes some sense now if we look back at the, and you can also have it open, so it can be grounded, open, grounded. So you're selecting one way or the other. Either this capacitor or this one. So that's 2 in the tone control. Okay, I'm going to take these guys out and we're going to test them. One is long, one is shorter. Let's do this one first. Put a clip lead on that. And we'll put it in after we remove it. I'm just going to cut it off of there. I'll leave the other one in place. I'm going to do two things at once. If I do two things at once, there'll be trouble. Trouble will occur. Now, what's the big deal if this capacitor is bad? If it doesn't have any capacity, it's not going to do the tone job it's supposed to do. If it's leaky, we have to look at the schematic again. And in these capacitors, when I say they're leaky, it's not like there's current rushing through them or anything like that. We're talking about really at the level of charge flow as opposed to current. Okay, here we go. Watching the eye, and the eye says, hey, popped open. 150 volts. Not happening at 150 volts though. Usually when a capacitor fails at 150 volts, it does a pretty bad job even at 50 volts. That's a little different. Okay, I'm always trying to read the value of this because now while you're looking at that, I might as well cut the other one out. Why not? I know where it came from. Let me just get it out of here. Okay, here it is. Probably going to test the same. Okay, 50 volts to start. You can't see it, but it's cracked open ever so slightly. It really hasn't opened at all. So bad guy, bad guy. Leaks on these capacitors. Let's look back at the schematic. Just get some appreciation for the impact that might have on the radio, which I don't think is much, but let's take a look. Okay, so we consider this one first. Let's suppose it's leaking so bad it's virtually a short. Then with this tone switch, oh look, the way it's indicated is very clear that the lever, the lever is grounded. Okay, so if this were a short, if this switch were as it is now, nothing would happen because it's not connected. But you flip this over, well, you put a short right here, and the radio works. So I think if this were shorted or leaking so bad it may as well be shorted, I'm not sure that can really happen. You're kind of getting the same result as if you just flip the switch over here. So immaterial, except the tone variation won't be what was intended by the design engineer if it's leaky. Now the other one's this one. This one is connected. So if you throw the switch to it, you put a ground right on here. So if this were shorted right out, you would be shorting all this out. And this is the plate. So you'd have plate voltage shorted through this capacitor to ground. Now it's not shorted, but it's partially shorted. It's leaky. Not very leaky. This is the better of the two capacitors I tested. This is the one that was very leaky. But let's suppose this one is quite leaky. What would happen? So the question is, what is the impedance of this part of the circuit? So if we assume no leak and no leak, then from a DC point of view, this way goes to the plate, goes nowhere. So very high impedance through here. Now you meet up with this resistor. It's 500,000 ohms. That's kind of a medium impedance. So The reason I'm raising this is you can think about how much charge is sneaking out through this capacitor, and will it bleed down the pressure in this area, or will the pressure be maintained? Now, where's it getting its pressure from? Well, it's getting it from the power supply, so there's an endless supply of power, or voltage here if you like. A certain amount of current is flowing in the circuit. It's a plate circuit, so the certain amount is actually quite high. I don't know, 10, 15 milliamps, I don't know. And so what if you leak off a few microamps this way? Well, nothing. Nothing's going to happen, because there's lots of power. We're going to, although it looks like it's high impedance, it's really not. You really can't consider it that way. It's not like a grid circuit or something where a little bit of charge is going to make the voltage vary. That's not going to happen here. So again, leaky capacitor, really no consequence, except the tone quality. Maybe if it were leaking bad enough, maybe you'd flip here and the volume would be reduced a bit. I don't know. Low impact capacitors, I believe. That's my take on it. Something you need to be aware of if you're fairly new to my videos is that I'm doing my best to identify how these things are working, or what a particular part does, but I can easily be wrong. In fact, it's easier for me to be wrong than right. So you need to take everything I say with a grain of salt. If you're trying to learn about this stuff from me, this may not be the best way to learn, because I make mistakes and I say stupid things at times. Okay, we're going to put the two new capacitors in, and then we're going to take a look at this guy here, the last of the three. So we come down to the volume control. This is the part you're turning or sliding. There's a capacitor right there connected to that and conveying the audio up to the grid of this tube, the triode grid. So all the audio in the radio passes through this capacitor. This part of the circuit is very high impedance. See, this is a 10 meg resistor here. So it doesn't take much charge, if you like, to affect the potential of this wire here. So this is usually a shielded wire through here. They don't seem to indicate that here. Let's look down on this diagram. So here we are. Here's the center post, and they do not show it as a shielded wire. They just show it as this capacitor, the one I'm about to change, C16. The shielding is on this wire, which is conveying the audio signal from the radio portion of the radio to the volume control. And then they have this is not shielded. Maybe this isn't shielded here. They don't actually, yes, do they? Switch and cable socket, I don't know. Don't worry about it. It won't matter anyway. So this is the capacitor I'm after, C16. Double check, C16.0025. The voltage this thing experiences is next to nothing. There's no DC voltage here of any significant amount, so any low voltage capacitor will do the trick. 0.0025. Okay, I'm going to put that in there. Well, I'm going to do. I'm going to cut the capacitor out. We'll test it. Okay. I think I'm going to put a clip lead on there. And we're going to the center post of the volume control. I will remember that. Okay. There he is. Okay, let's go over here. Okay, this is your chance to impress us, Mr. Capacitor. Let me just, I got too many lights on in here. There it is. capacitor there for a minute. So what would happen if this guy's leaky? Well, you know, this is protecting a high impedance circuit, but there isn't much pressure pushing on it. We'll have to take a look and see what how the DC is handled in this radio. The AVC DC. Here we go. Well, it opened about halfway on 50 volts. It's not going to open on 150. So again, just like all of them, a little dilapidated, a little leaky. The actual quantitative volume of charge leaking through here, I have no idea. I just know its relative quality compared to many other capacitors that I've tested. And this one's typical of an older capacitor. Let's take a look at the circuit and just ponder what a leak would do in this particular, with this particular capacitor. Okay, so we're pondering about this one right here. So what, you know, unless there's some DC pushing on it, it doesn't make really much difference if it's leaky. Let's take a look and see. So the one end of the volume control is grounded. The other end is coming, it goes way up onto the push button switches to get switched, and then it comes down through a resistor. So what I'm seeing here is there's no capacitor in the way to stop DC from coming from this point all the way through the switch, all the way back to the top of the volume control. That's quite common in a lot of these radios. The AVC voltage, or the detector voltage that develops because of the rectification that's going on here, rectification of the output of the IF, that voltage, which is sent off to control the gain of the first couple of tubes, that potential is also presented right through, or is causing a current flow right through this resistor, right through the volume control. Now, what kind of voltage would be here? Well, the very most voltage you would get, assuming a really strong station's tuned in and the AVC is maxed out, minus 15 volts, 20, I don't know about 20. So let's say 20. We'll use 20 volts. 20 volts is also divided here, and so in the end, what do you got left? 10 volts. So a leaky capacitor here, because the circuit situation is there isn't much pressure pushing charge through it, probably wouldn't cause much effect here. But you hear me say I'm using a lot of caveats, right? Probably, maybe, all that kind of stuff. I don't really know. We could try measuring this, but it's very tricky to do. For instance, the input impedance of my voltmeter is 10 megohms, the same as this resistor. So if I hook up the voltmeter here, I will change the resistance here by a factor of 2. Is that? I think you're following what I'm saying. I can't put a voltmeter on here and get a real reading. Or can I? And what would I get? So I do have a voltmeter with 125 megohm input impedance. I could probably put it on here. Would drop the voltage slightly. We'd get some idea. What would we get? So what's over here is a negative voltage too. So if a little bit of a negative voltage leaks through here, well, it's not the end of the world leaking negative onto a grid. Increase the grid bias here a little bit. Best thing we can do is just change this thing and stop talking about it and not worry about it. I like to analyze these things. Occasionally I'm visiting something kind of for the first time, analyzing it, another layer down, so that's why I might dwell on it. But that's the situation here. I don't think a leak is very important. 0.0025. Okay, I'm going to stick a new capacitor in there. Okay, time to test the radio and see that it still works. Let me just put a few tools away here. So I have another gray day. Months ago I mentioned in the spring actually that I acquired a nice telescope, and I have had some nice fun with it at night. But the fact is, the conditions have not allowed me to use that telescope virtually the entire summer, later summer, and right up until now. It's just cloudy all the time. It's really kind of disappointing, because I would hope for some nice clear skies with very low humidity in the air, and you get a really good view. Plus, at this time of year, because the sun has gone low in the sky. It gets much darker earlier, whereas in the summer you gotta wait till midnight, later than that even, to get a really, really dark sky. I really gotta be up around 2 in the morning, and I'm never up at 2 in the morning. So unfortunately, although I have managed to take about 100 astrophotographs with it of different objects, not 100 objects, but many of them I photographed again and again, I'm actually not getting a lot of use out of that thing because the weather has not allowed it. Very disappointing. So, okay, enough talk about that. Let's fire this guy up, and another unfortunate choice of words there, and see that it still works. Okay, volume is down, and I gotta stop. I'm gonna switch the antenna on down here. Okay, so I've attached my outdoor antenna. The antenna I'm using is this little E antenna. There's no wire, it's just a small plate. Literally about this big, and attached to the plate is a amplifier, high impedance input amplifier. It's a FET, it's a MOSFET amplifier. And then the signal is sent right from there. This is right up on top of it's basically a long stick I'm using in my backyard. And the signal comes, it's boosted by this amplifier, and then sent down the cable to the radio, all the way into here, all the way onto this cable. It's a long journey to get to here from the top of that antenna. So wouldn't be surprised if a fair bit of the signal is lost along the way. But we're going to give it a go. Here we go. Okay, dim bulbs behaving properly. Nothing else yet? Don't know what band I'm on. Ooh, here we go. Okay. Good volume control. Tone. Okay. Sounds like we're on the broadcast band.
Babies and several have died. City News, an Ottawa man being investigated by Toronto and Ottawa Police hate crimes units after allegedly being caught on video inciting hatred and expressing anti-Semitic views. He was charged by Ottawa Police with breaking several bail conditions, but was arrested near Toronto, which is why both forces are investigating. And after a weekend of celebration, the Hockey Hall of Fame
no pointer.
ceremony is set for tonight. 5 players and 2 builders will be in trouble. John DeWitt is extinguishing people every day. I'm like, what?
Wow, we've heard enough already? What's that? I don't know.
Because they are anti-gay.
That's enough.
Women,
That's enough to prove the radio is still operating despite the work I've done on it. Fantastic. So just to talk a little more about that antenna, and I'll probably do a video on it when I become absolutely certain of its operation, but I'm pretty certain already. For me, what has happened in my house is a revolution on 2 levels, a radio listening revolution on 2 levels. One level is I've eliminated the noise in my house, virtually eliminated it, by getting rid of 2 clunky computers I've been living with for 15 years anyway, and been upgrading them a little bit along the way, new video cards, stuff like that. But the result is both of those computers issued vast amounts of noise all across the band, whether they were operating or not. So if I just click, shut down, the 2 computers just kept barking out noise, and for some reason I didn't have the brain power to figure that out. I can't believe it. So, not realizing this, I have hunted high and low for noise problems in my house. Well, those 2 computers are gone because I upgraded them, and as soon as I did, all the noise went with them. Not only the radio noise, but even the audio noise of the fans. The fans in these computers were noisy. You would have heard them in all the videos I've done up until now. But if you hear a noise now, that's my furnace running, in fact. So that's not the computer. So fantastic improvement in dropping of the noise, a huge amount, revealing all kinds of radio signals that were covered up before. I could never hear them. So what I've been doing the last couple of weeks is in the evening I've been listening to AM radio from across North America. There's something like 10,000 AM broadcast stations in North America. The United States is full of them. Many of them are very, very, very low power, 50 watts, 20 watts, stuff like that, very local stuff. But among them are these big powerhouses, 50,000 watt stations. And I've been able to pick up more AM radio than I ever have in my life. Part of it is, big part of it, dropping of the noise, but the other part is this E antenna I'm using. So I keep ranting about it, but I'm going to have to show you more about it at some point so you know what I'm talking about. There are two versions of this E antenna, both of them designed by ham radio operators somewhere in the world. And they're being manufactured, I think, by various people. So not necessarily coming from the ham radio guy himself by any means. I mean, so anyway, there we are. Great. Radio's working. Okay. Good. I'm done. I can stop talking now. Thanks a lot for watching, and I hope you're getting a kick out of the video as I proceed with this radio. We'll be doing the RF circuits next. Have a great day. See ya.